Hello everyone, this is Joseph Porter, your host, and you're listening to The Next Layer. In this podcast, we're looking to explore the world of additive manufacturing, from hobbyist applications to complex engineering solutions. Our focus is to not only learn about the current state of the market, but where it is going and how individuals like you and I can take part in these trends. We'll be interviewing hobbyists, engineers, and scientists, discussing new techniques, applications, technology, and discovering what the future of additive manufacturing will entail. Whether you're an aspiring creator or a senior research scientist, we hope that you listening are able to learn something new. We'd like to thank our sponsor, MarketList.com, for making this episode possible. MarketList is an online contract bidding platform for additive manufacturing where local manufacturers have access to a wider range of work that they can bid on, and clients can receive offers that best fit the needs of their project. If you're interested in saving time and money on your next 3D printing project or taking on more clients for your business, stop by MarketList.com. The link is in the show notes. In this episode, I have Benjamin Obeng on, who is the founder of 3Dinkra. In it, we discuss his journey thus far through 3D printing, starting all the way back in college. We discuss generative design, where Benjamin hopes to see the market go, and most importantly, what is 3Dinkra. Thank you for listening, and I hope you enjoy this episode. So I've got Benjamin Obeng on today to talk about 3D printing. Benjamin, tell us a little bit about yourself.
Hello guys. My name is Benjamin Obeng, and I'm originally from Ghana, and I'm currently the founder of 3Dinkra, which is a 3D printing startup in Ghana. I'm also currently the lead additive manufacturing engineer at Siemens Healthineers. I grew up basically most of my life in Ghana, and then came over here to study to do my master's degree in mechanical engineering. And then I caught on that wave of 3D printing, and I was so fascinated about it. So I jumped onto the wave and never looked back. So basically, that's me.
That's awesome. So when did you initially come over to do your master's, and where did you?
I came over in 2017. That was about 3-4 years ago.
Oh, fantastic! So it's pretty recent that you've dove into 3D printing as a whole, and it seems to be that you've made waves ever since starting in that.
Yeah, I'd heard about 3D printers. I'd seen 3D printers in Ghana, because my university back in Ghana, we had 3D printers there. Not amazing and huge ones, or fascinated ones like that, but we had just started, actually. Let me say, we just started looking at 3D printers. But when I moved over to Arizona State University, that's where I studied. We had a makerspace, and I saw the 3D printers there, and took opportunity of them, and actually kept using them. And I actually worked in a makerspace, in the ASU makerspace, for a while, and that built my experience and my love for the 3D printers. And then I actually built the actual experience, 3D printing experience, from then. Yeah.
That's what, honestly, that's a really great point. Is back when I went to school for engineering, we had these makerspaces as well, and for me, like when going through high school and whatnot, I never really touched a lot of engineering topics.
Mm-hmm.
I was mostly like all my interests were outdoors related versus engineering related. So when I finally came to college, I mean, a lot of these really cool applications, such as like 3D printing, was just kind of getting some grips in the makerspace when I first got there, and we had like an Ender 3 or like an Ender system or something like that. And that's where I also, college is where I first got introduced to this. And when I my first internship, and I was like, oh, they use 3D printing here. I was like, how the heck do you even get started on this? Like, this is so cool, but I have no clue what I'm doing.
Sure.
And so yeah.
Yeah, I think it's the same thing. My personal experience actually with 3D printers were at ASU Makerspace. I think it was a week after I was on campus, and then a friend of mine actually I went to his room and he had a 3D printed piece, and I was like, "What's that?" And he's like, "Oh, a 3D printed piece, and it's from the makerspace, and it's free to use, and you don't have to buy any material." And I was like, "Whoa, let's go!" What are we waiting for, right? So, so then I literally used the makerspace literally every day. I went there with files to print. And so I spent more time there than even the student workers. And so the manager over there was like, "Hey, you come here more than the workers here. Why don't we give you a job?" And I'm like, to pay me for something I already love doing? Let's do it.
Oh, that's amazing.
Yeah.
Wow.
That actually exposed me more to the 3D printing side. And I got to do more research on them, and learned how to fix printers, learned how to work with them, operate them, and knew what was coming next, like the latest brands of 3D printers there, and started buying my own 3D printers to use at home and things like that.
That's awesome. And you said you got exposed to 3D printing back in Ghana as well. Did you study mechanical engineering in Ghana?
Yeah.
Okay.
Yeah, I did my bachelor's in mechanical engineering in Ghana, but it wasn't. I didn't have any. I'd seen a 3D printer just once, right? I've heard of them, but I'd seen a 3D printer just once. Never used it personally until I came to the ASU.
Gotcha. Okay, that's awesome though. So in that makerspace, then, what kind of 3D printers did you use, and I guess kind of like what was some of your favorite projects?
Yeah. Yeah, it's interesting. So what we used, we mostly had MakerBots. We had a lot of mostly MakerBots, and we had a Zotrax, I think M3. And so it was really interesting because I was at the time I was also working on a research and more on working there. Usually I started printing. So there's a group of structures called, I don't know if you might have heard of them, the triple periodic minimal surface structures, the EPMS. So these are really cool structures that they occur in nature, but before 3D printing, you couldn't make them, but they were just mathematical equations, right? That occur in nature. So you think about like the type of cell designs in the cross section of a bone, those kind of intricate structures. So, for example, a popular one is gyroid. I think now you can actually have infills of gyroids. You could have gyros at infills in 3D printed parts. But there's a whole list of those structures. So that was basically my research to actually utilize them and say things like 3D printed heat exchangers and other cool stuff like that. Because I used to work I used to be a researcher in a thermal lab, thermal engineering lab. So I used to 3D print these structures and try to see how we could use them when in certain applications like heat exchangers, for example. And so I was printing some cool structures and some cool stuff. And so that actually, because my parts were cool to actually watch, right? And so that's another thing that drew my manager's attention to me, because people were coming up were bringing in some toys to bring. I was bringing some cool stuff, right? And it was really fun, and I was fascinated by the ability to just design something on CAD, either from SolidWorks, Fusion 360, or whatever it is, and then you can have it made, right? I was just totally blown away and fascinated by that, and actually see your product and hold it in hand. And that's something that I never had the opportunity to do or to experience. And so that's really huge. And I think most of the projects that I worked on were more of in the research side, but some of the cool stuff that I also made outside of the fun stuff were basically 3D printing some toys and some stuff for friends, right? Which could take advantage of, and that was also fun, right? In the makerspace mainly, I also we had sessions where we taught people how to use CAD. We taught people how to use the 3D printers, and usually people send jobs to be printed, and so I also partly managed the queue, the print queue, and that also exposed me more to a lot of stuff. I remember some of the projects that people were bringing in cool projects for us to print for them. One of the projects that they brought in was there was this graduate student who was actually working on a piece for I think it was an archaeological piece, right? And he had 3D printed. They had scanned skulls of I think apes in a different country. I've forgotten what the country was, and they had sent the files to him, the scanned files to him, and then he 3D printed them and did some cool stuff with them, and it was amazing, right? He overlaid clay on those 3D printed parts to actually for them to actually come real. Like it was so cool. There was another project that I worked on with the university, which was on Mars. So there was this what do you call it? This asteroid. I've forgotten the name of the asteroid. That was metallic in nature. So they had an idea of what the asteroids look like, and then we were to design and print it. And it was there were a lot of cool projects. One other project that I worked on was so I was tasked to actually design an award actually for the Grand Canyon. There was a ceremony, an event, the Grand Canyon 100-year, I think, anniversary or something like that. And my boss actually from the makerspace tasked me to design some awards for some contestants on that for a competition that they did. And I came up with some really cool 3D printed designs, and I played with things like being able to 3D print geographical features, like converting maps into 3D pieces or 3D objects, and actually printing them. And so there were a lot of stuff that we worked on.
So a wide set of projects that you've been working on. Dang, that's awesome to be able to see that, working on just personal projects, the different kinds of structures too. It just sounds so cool, because I think that's an area where 3D printing is really, I guess, pushing forward the dynamics of mechanical design, like things that weren't previously possible to see some things online too, on like LinkedIn and whatnot, where these guys have this software that like optimizes the best like thermal extraction and stuff, and they can 3D print that, and so it's just these new things are I feel like it's kind of reinventing the way mechanical engineering is done in a sense, because now you have a whole wider area of like a playing field for what you can do. Things that weren't possible previously are now possible, especially with like the way metal 3D printing is really accelerating. Because previously, like plastic, okay, like an FDM printer, you can print some cool stuff, but like that print's gonna break, at some point, or it's gonna shear or whatnot. So the farther this evolves, I think it's gonna be really fascinating to see how this takes over the space, and then also designing something for an asteroid and working on it. It's just wild.
It's
you're quite involved in that makerspace. That's super cool.
Yeah, it was super interesting. And the other type of project that we worked on, I remember we had a session where we brought in I think the middle school kids came in one summertime, and we taught them how to design in CAD, right? And one of the projects were to design kind of like utensils or stuff that if they're supposed to go to Mars, they can take with them, right? And the constraint was to take into consideration the limitations of space, right? You don't want to carry everything along. So you can come up with this, because we wanted them to understand the limitless design opportunities with 3D printing. So instead of coming up with, and they came up with amazing stuff, like stuff that you wouldn't think of. So for example, instead of taking a spoon and a fork, you take together like a spork, right? Right? They designed a spork. Instead of having a bowl and a plate, they named it blade. Kind of like some cool stuff. It was really interesting. Like they came up with some amazing stuff that you could use one stuff for multiple things, right? So to save volume, and that's something you might not even be able to do with, let's say, injection molding. but with 3D printing, you could actually make those parts. And to draw back on the point of the where 3D printing is affecting the modern forms of engineering, I think that the capabilities are wild, right? You have now the entire space of optimization has been changed, right? So you spoke about with thermal analysis and things like that, softwares like that. So you have softwares like topology coming up, and even now you have Fusion and even Answers actually coming up with projects where you can have generative design features and optimization features, which takes the entire efficiency of engineering products to a different level, right? So now it's only you're only limited by your computing power, right? And that's crazy. That's amazing. And so the future of it is wild, I think.
Yeah, I totally agree, and I think generative design too. Just seeing some of those different prints. We had a guy named Daniel Costello on. He some of the prints that he sent me to post as well were generative designs that he did, like for his wife has like a VW Beetle, I believe, and so he made a new knob for it that yeah, like a new shifting knob that was like generatively designed. I was like, wow, okay, like this is so cool. They metal cast and everything. So yeah, it's just like stuff like that, just endless opportunities of design and all these other various things. I mean, we're really hitting new like levels of innovation, I would say. And it's kind of cool too, because with the advent of because 3D printing's been around for since like the 80s and before, but for consumer style stuff, for where we both kind of got introduced on it, that's only been around since like the 2010s almost, I would say. So I think we're finally hitting a point, where it's been about 10-ish years or so, where innovation's kind of like everyone, now that so many other people have been exposed to this, like it's just really kicking off, right? So because now everyone kind of has a chance to really get involved in this and push it forward, because there's so many things to just change and innovate on with 3D printing. So then with your experience, you say you're the co-founder of 3Dinkra, and then you're also a Healthineer, additive manufacturing engineer. Let's talk a little bit about those things. So I guess then, what is it 3Dinkra?
Yeah, it's Adinkra. It's basically like a play of words. So in Ghana, in our alphabet, right? What we know as 3 actually is a letter in the alphabet, and it's pronounced E, right? And also we also have a group of symbols in our culture, a group of symbols that have meanings to them, right? And so it's a cultural thing. In a cultural thing, we have all these symbols which actually have meanings to them, and all these groups of symbols are called Adinkra, right? It actually explains our culture more, right? And so I was actually playing with the words, and instead of having, and it's spelled Adinkra, but because we're using 3D printing and what we do, I decided to do it 3D. So and it's still pronounced Adinkra. So when most Ghanaians see that, they would pronounce it Adinkra, right? But a lot of people, because we are in the 3D printing space, they say maybe 3D or but it's pronounced Adinkra. So it's just basically a play of words, and we usually like it when people ask us, hey, what does that mean, or what is that, right? And we have the opportunity to actually explain it inside our culture. Yeah.
Wow, that takes the cake for one of the coolest names of a company that I've seen. I didn't realize that. Thank you for explaining that, because that's wild. Because I feel like when you try to do like a startup and you try to picture what would be a great name, to do something. Wow. Okay. So that's that's amazing. So
yeah.
Tie-ins there with the 3 and everything. Wow. Okay.
Yeah.
That's really cool to know. So Adinkra. So what is it what's your vision with Adinkra? Why did you start it, and where are you planning to go with it?
Okay. Yeah. So I as I said, I caught the wave of 3D printing, and I was fascinated about it, right? And seeing the limitless opportunities that it's able to bring, and it will be bringing. And now in the future, I thought of it as being able to as a tool that could actually help not just Ghana, but the entire African continent actually leapfrog in multiple ways, right? And so instead of maybe coming up with going through that entire manufacturing setup, right, where you need to have like a huge injection molding piece, and then you have some personnel set up and all that before you be able, and maybe material before you be able to start something, right? Those huge initial costs. 3D printing actually is able to enable us to leapfrog in all that, to be able to actually have manufacturing or manufacturers even with less amount of those crazy amount of processes and those crazy amount of things. And so I thought it wise to actually 3D printers already exist in Africa and most part of Africa, but it's not as big as it is here, and we thought to actually make people understand the abilities and the capabilities of it, right, and make it huge. And so our focus mainly were two things: to actually educate, right, and then to be able to come up with cool products, right, that people can actually say, hey, this was made out of 3D printing, right, and actually to help the entire African continent leapfrog in multiple ways. And so I decided to do some proof of concept. So I purchased some 3D printers. I think about 5 3D printers. That's what we started with, and both FDMs and SLA mostly were in the 3s. Yeah, and so thank God for in the 3s, by the way. Mostly in the 3s and SLAs, and shipped them over. Spoke to a couple of friends who I graduated KNUST with. So KNUST is Kwame Nkrumah University of Science and Technology. That's the university I graduated with my bachelor's. And so I spoke with a couple of friends who I graduated with and said, hey, I'm shipping over some 3D printers, and let's see how it goes, right? And so when I shipped them, my friends didn't know how to use 3D printers, but they got there, and so I taught them how to use it effectively, and we were about to actually we did some basic proof of concept to actually know what markets were good for what we were about to do, and the problem with most 3D printing startups or businesses in Africa is that they usually pick the models that exist in the Western world and want to directly fit it in Africa, and that doesn't work, right? In businesses, you have to actually understand your customer, right? And customer and what the customer wanted or was different from what the customers here in the West actually want, and so we noticed that it's either two things. You either come up with a product in that high value chain, or you're able to shorten a supply chain using 3D printing, right? And so we did some market research, and we noticed that a couple of industries we could affect a couple of industries, right, with 3D printing, and one of them was the jewelry industry. Right, we do other stuff, but the jewelry industry was one of the main ones that we targeted, right? And for two reasons. One of the reason is the amount of impact we'll be able to make, and the statement that we'll be able to make in that. Because although 3D printing is really cool and amazing, there are still a lot of manufacturing processes that still beats 3D printing when it comes to certain factors. For example, cost, right? Comparing injection molding, for example, with 3D printing on a cost level might not make sense at the moment, right? I say at the moment because a lot of companies are still working on things to be able to make the process faster and relatively cheaper or the same. And so those are some of the reasons why we targeted the jewelry industry. And at the moment, Ghana is, when it comes to the gold producers, Ghana is number 1 in Africa and seventh globally, right? When it comes to precious minerals, Africa alone produces about 97% of the world's precious minerals. Can you believe that, right? But yeah. But the issue is that we export all these precious minerals, right, to different parts of the world, and And yes, we get some money from that, but it's not, it's insignificant compared to the entire precious mineral industry, right? And so because we don't have a really innovative, I would say, jewelry industry, right? And most of these jewelries have to go to places like, let's say, China or India to be made into jewelries and brought back to us. And so the entire supply chain, the jewelry industry leaks, right? And so, yeah, what we wanted to do was to get into that and shorten the supply chain and make it easier and block those say problems or those leaks. And so we collaborate with jewelers, right, and actually introduce 3D printing into that entire system. So we're able to make limitless designs, right? We can compete with on a global scale with what types of amazing designs that we can come up with, and then combining it with the custom experiences with these jewelers, we're able to come up with cool products. And so that's one of the main things. But the entire vision is to actually incorporate and infiltrate 3D printing into multiple industries, not just the jewelry industry, but multiple industries in Africa, not just Ghana, but in Africa. And I think it's really going well.
Yeah, wow, that's fantastic. I mean, just like the whole mission there of being able to come back, bring kind of help the African continent just like explode with 3D printing, just kind of bring it forward with the education on that, and then also develop amazing products and shorten up that supply chain. You found like a great niche area for, I mean, this is amazing that you'll be able to kind of find that, target that, how to execute it, and then you're just going to be able to bring it forward. I can only see success going forward with that Addinkra. And just, I mean, your guys' post about that 3D print, I mean, that thing had a huge footprint, everyone saw that in the 3D print community, it's like, dang. So it's just kind of, yeah, because it's such a beautiful area that you chose too, jewelry, so it's one of those things that really catches your eye. It's
exactly
just a beautiful, artful area, and it's a very niche area of 3D printing that's just super cool to see. And your product that you turned out with that was amazing, right? Because sometimes you'll see these little kind of like centering lines or something like that. That's kind of hard with the post processing, but it was a very beautiful piece that was produced there. So that's a great area that you're working into there, and yeah, amazing.
Yeah. Thank you. And you could see that a lot of people had connection with that problem, right? And reading the comments was amazing. The number of people who are connected with that problem and saw the need for something like that. And so it's really interesting. That also boils down to education side of it, right? And we're planning to actually do a lot of work with schools and partnership with schools to actually come up with more cool products and more cool stuff. And yeah, I think it's so far it's going well. And yeah.
Dang, yeah, that's I can see that only making huge impacts, because just the way that 3D printing is exploding even over here, and just I can only imagine the way introducing this, shoring up that supply chain, getting better returns for the jewelers in Ghana, and also in that gold industry to be able to produce that. So I mean, just all around, just really helping the community there, helping bring forward the engineering there. It's just on both sides of it. That's phenomenal.
Yeah. Thank you.
Yeah. And then also, I guess, with you said you work at Siemens as a health part of the Healthineers as a manufacturing tech. So if you want to, what do you I guess let's talk about that then a little bit. What do you work on there, or where do you see yourself working on there, and what projects are you going forward with?
Yeah, so I'm the lead additive manufacturing engineer with Siemens. So I'm basically still in the world of 3D printing. Yeah, so Siemens Healthineers is just a medical device industry. So Siemens is the mother company, right? And one arm of it is Siemens Healthineers, medical device company. So we make different medical device diagnostic products and things like that. And we use 3D printing in the entire R&D space to actually do more R&D stuff and test some designs and things like that. And so basically what I do is manage those 3D printers and also do basic inspection for certain parts that we get from outside. So basically, that's my space. Yeah.
Very cool. So how did you get it about working on that, or how did you get introduced to that role?
Yeah, I think I graduated from ASU as a mechanical engineer, and actually I got a lot of ties to, as I said, thermal energy systems. So I should mostly be in the thermal side, but I love 3D printing so much that I used it in multiple stuff, and I worked on multiple projects. While I was in school, and that broadened my entire scope and my entire field. And so basically, I was hoping to actually get a job in 3D printing. I could have gotten a job in different spaces in the mechanical engineering space, but I think I really wanted something in 3D printing because I really liked it, and it worked out because I worked with some company, a company after school that I used to help them. So they made products for people who had inventions and they wanted to actually make their MVPs, minimum viable products. And so I worked with them for a while to actually use 3D printing in most of the designs and most of the products that they come up with. But I ended up getting an opportunity with Siemens, and it's been amazing ever since.
That's super cool. Yeah, it's just great. I guess in different engineering fields too is what I realized when I finally got into the engineering space is that there's kind of like a wide variety of things you can work on within your major. Like I thought I was gonna be kind of shoot in sometimes as an optical engineer to like a very specific task, but like I've been able to work on. I even was able to bring 3D printing into the role, different areas, or work on programming and stuff. And it's kind of like I feel like sometimes when people see that you're really good at something, they want you to work on that, right? Or something that you're really excited to work on. So with your interest in 3D printing, and now you're the lead, manufacturing engineer with 3D printing, it just makes sense, after hearing, where you started with 3D printing and what you've been doing along the way, it only makes sense to put you in a role like that, So like kudos to the Healthineers and Siemens for seeing that, and because like that is I can only imagine the work you're doing there is phenomenal. So
and my basically my resume is full of 3D printing stuff and 3D printing project. So it's although one might say, oh, it's just a few couple of years, but looking at projects that and the things that we worked on, when you're counting the hours and the time to spend and 3D printers, that's crazy, and it's enormous. And I think the growth has been exponential instead of being linear. It has been exponential. So that's one thing I'm really happy about, and I'm really interested in that field. Right? It's not maybe someone who maybe it's just looking for a job to fill a space, right? But something I'm really interested in, right? And so you get to see that kind of passion and that kind of connection to put me to that the 3D printing space.
That's very true. And it's just with the way the market's going with 3D printing and the amount of innovation it's had. It's an exciting time, to be in this field. Just with the way it's going, there's just like leaps and bounds being made by different academic areas, by different companies, and it's just super exciting because traditional engineering, you'd see like a fun fact about optics. I would say, and some people might slap me inside the head for saying this, but the field almost died out back before the laser was made, right? Because you can only do so much with the light bulb or so much with like solar, with a lens. So before that, it's like the field was like kind of slowly etching towards death, and then all of a sudden the laser comes out and the field just explodes, right?
Yeah.
And so now we have optical, everything. People have laser pointers, even. It's just kind of like it's crazy, right? When people kind of, all of a sudden these different things happen. And also, I mean, it made a huge impact on 3D printing with like the different laser systems, the selective laser sintering and all that stuff, and then also the projection and whatnot. So I think that's kind of where 3D printing is right now. It's in the explosion phase, where it's just it's like hold on tight because this rocket's flying, and there's new stuff coming out left and right. That's just super cool. So I shared in that excitement, for working in this industry to see where it goes. and one model we can it's just exciting, to explore that area. So I think that's on that topic. Where do you hope to see the market go?
Ooh. Yeah, it's actually there's no point, right? There's no end point. Like, honestly, like it's limitless. That's what I was saying. But you get to see. I think I get it. 3D printing has started infiltrating into multiple industries. It has already started in doing it. So now you have 3D printed rockets, right? You have 3D printed in the medical field, for example. It's wild, right? So prosthetics and things like that. Now you have 3D printed implants, right? You still utilizing some of these amazing structures like a TPMS structures, right? So I think it's limitless. So now what the motive now is we already have systems that are working, right? But now people are trying to optimize already working systems, right? To make them more efficient. You get my point. So for example, now let's say rockets, right? So to ship, let's say a pound of load, right, to space costs huge amount of money, right? So, but now with, for example, things like generative design, you can reduce that amount of pounds by huge. So it's huge cost savings, right? When it comes to, for example, 3D printed rockets, right? Because now you're using the least amount of materials to give you the optimal amount of strength or optimal amount of efficiency, right? Which is crazy. So now you're saving a lot of money, right? So now you're boosting the efficiency high. So when it comes to things like heat exchangers, right? Now you're using all these cool designs to actually make them more efficient. When it comes to the automotive industry, right? People are now saving a lot of money when it comes to companies like Ford or BMW or all these different companies. They're using 3D printing to actually reduce cost, make things more efficient, right? And so I think it's infiltrating in different industries, right? Which literally makes the market limitless or endless. And as I said, it's now all boiled down to your computing power, right? So if you're able to, if you have huge computing power, you can be able to process some of these generative design features or these designs onto a point where it's really, really high up to optimization points. But I think generally 3D printing is growing really wild, and as you said, most of us actually jumped into it before maybe 2010-ish, 2007-ish. Most people didn't know about 3D printers. It was these huge machines in like high-end companies, right? But now, because of most of these patents like expiring, you have most of these companies or smaller companies making these 3D printers that we can use. And so I think in the future, it might even get to the point where literally every home must have a 3D printer.
Yeah.
Yeah, where kids can work on projects. It was part of a toolkit, right? For engineers, it's a no-brainer, right? Where or designers or cool, like I think basically it's endless, because now even in the medical field, right? When you 3D printing is not an island, right? You now you're able to combine it with a lot of stuff, like let's say VR, right? Virtual reality, right? People are combining 3D printing to VR, right? People are combining it to AR stuff, right? And doing some really amazing cool stuff. Now you have 3D printed buildings, right? Which is also taking wave, right? They just listed a house in Long Island, right, in New York for sale, 3D printed house, right? Which is wild. In Germany, they just granted the permits for a 3D printed apartment and a 3D printed house, right? Which is really crazy and really wild. And so you get to see the space infiltrating, like the technology infiltrating literally every space now, right? Now even in space, you don't have to. Initially, they had to ship every tool over to space to the space station to be used, right? But now you just have to send the file. They have a 3D printer in the space station, and they just have to send the file, and then they can print those tools there, right? So it's wild and it's interesting, and I think it's fun, and so I think everyone should take a seat and enjoy the ride.
It's super exciting to see where it's all going. Like you mentioned some great applications, like 3D printing homes, right? Who would have thought that would be kind of like a commonplace thing coming up here soon? Because I know there's this one startup that was kind of following. I think it's in like Florida, and they're doing like 3D print homes for like $4,000 or something like that. Or I forget what exactly it was, but it was just like, wow, you know, and you can set up the foundation in like no time at all. Super cool to see. And you know what I'm really kind of surprised in is that a company like Home Depot or like Lowe's has not integrated like some sort of metal 3D printer on site, because you know they had those huge like tool sections where they had like tool bits and all that stuff, and so I'm surprised. And you know, Home Depot, if you hear this, and you know, you better sign me.
I think it's coming. It's coming. And on that point, actually, so you have company now. Initially, you used to have a lot of these big automotive industries saving or storing inventory for let's say spare parts, right? And some, but now most of these companies don't have to store that inventory. So let's say you give them a call, hey, I lost maybe a part of this brake system, right? All they have to do is they usually have those files, and because some of those vendors have gone out of business because those are old parts, especially for old parts. So they just 3D print it and then cast. They usually 3D print it and wax and then cast it and clean it up. And when you come, you just pass by and grab it out, right? And so it's some of the interesting things that, because you know, inventory is money, right? So you're trying to save cost and things like that, and it's really interesting.
I totally agree, and it's one of those interesting areas. I was approached, a buddy and I were approached a little while back about this. There's a certain like fancy car part, but the parts is like made in the 1980s, and it was a plastic piece for the switch for the windshield, or for the window to push up and down. There's like a part of that, and the bracket was broken that kind of like held it in, but no one made it anymore, right? And so it was kind of like, hey, I need this part. Like, can you guys make this possibly? Because you can't find this anywhere, you know? And so I was like, whoa, okay. You know, just opened my eyes, like, wow, there's a whole world of stuff that's about to start happening, especially this in automotive, like, as you're mentioning, of like all these cars that people love to have or restore, or parts that they need. And you can just go get those things printed now and then just pop it in, and it's amazing. So, I totally agree. It's a limitless market. It's not an island. And it's just infiltrating everywhere. I mean, it's just starting to pop up in every single corner of anything that's related to manufacturing. And it'll be fascinating to see how fast you can produce some parts in 3D printing, like the speed, because I know that's one thing is, you know, casting a part, and then also just 3D printing the part, right? Because there's a certain point where if you're trying to make like 1 million parts of a certain plastic part, right? It's a certain point where you just kind of go with injection molding or something like that, right? So, but it'd be interesting to see, because, you know, I would argue that 3D printing, I saw some articles out of like, I think it was Northwestern, where they're 3D printing like car size level parts in like an hour or something like that. And I think stuff like that is just gonna, you know, start hitting the market, and it's just gonna completely kind of it's gonna take a hit out of the injection molding industry, especially for a smaller batch.
Yeah, and I think those are some of the things that are heading the growth of 3D printing. So it's two things: the cost of production and also the time, right? And I think there are a lot of people working on it. For example, I think Stratasys has a separate company which they call, I think, Evolve Additive, and they've come up with a technology called the STEP. But I've forgotten the full meaning of that. But I think their motive or their goal is actually to compete with the cost and the time of injection molded parts. And I think things like that, or printers like that, will really make a dent in the entire will make a statement in the entire 3D printing industry. Right? If we're able to actually, not even if not like the same time, but something closer to injection molding. That would be really interesting. And so that has limited 3D printing into different industries, right? So because when you think about it, if you can produce parts at a similar or approximately the same time and relatively cheaper costs than it is now, you can be able to put it into different industries. But now those limitations keep them in certain industries until you involve or you add other manufacturing process to it, like casting, for example, right? So now with 3D printed, so now you can 3D print things in wax, for example, right? So instead of maybe 3D printing every piece, you can maybe 3D print the pattern, right? And then make it in the form of create the mold out of it, so you can reuse those molds and use regular casting processes. So it's something we actually did in Ghana, used for production parts, like casting industry. So we worked with some guys who were making actually spare parts, right, for cars, and they used to cast one particular type of part, and it took them about 2 hours to do the process, right? But we were able to use 3D printing to make patterns for them, which, like, instead of having one pattern, like, so what you use in the casting process, they call it pattern. So instead of having one, we actually 3D printed 6, right, at once. So now they can use that same time to actually make 6 parts instead of one. So now you're combining 3D printing with other already existing manufacturing processes to actually give reason to the time and the cost, right? And so those are some of the things that help it moving. But if there's a lot of improvement with the time, that would be really crazy.
Yeah, that's a very good point. Just enhancing those marketplaces that are currently existing and people's applications of manufacturing.
Yep.
It's interesting to see where that go. Yeah, as you said, like, 3D printers just infiltrating just kind of every corner, and it's popping up everywhere. So it'll be cool to see where everything goes here in the next few years. Because with 10 years or so, 10 years plus of innovation thus far, we've seen amazing leaps and bounds. So 10 years from now, who knows what we'll be?
Exactly. Yeah, that'll be wild.
So, and then I guess with that, and then kind of closing up here, do you have any tips or tricks or lessons learned about 3D printing that you're willing to share with those like seeking to learn new ways and methods of 3D printing?
Yeah, I'll just say one is 3D printing world, or the space isn't it's not a straight one, right? Because there are a lot of highs and low points with 3D printers at the moment, right? And so it's more of getting connected and connecting with people who are in the industry and finding more information about later stuff that is happening in the space. That keeps you more connected, and also it's a growing technology, right? It's a growing industry, and even with 3D printers, a lot of people would think that, wow, 3D printers are able to do all this cool stuff, right? But yes, they're able to do them, but they also have their downsides and the points where they or certain things that it can't be used for at the moment, right? I keep saying at the moment because it's growing it's growing exponentially. Tomorrow it might not be the case, right?
Yeah.
Today we might be talking about a time about 3D printing to 3D printers. Tomorrow there might be a machine that comes out and they're like, we print at half of the time of injection molding. That would be crazy. But it's really interesting, and I would say that if you have the opportunity to actually jump into that space, at least that'll be really great, because it's catching fire really well. And to anyone who is like me from a developing country, if you think of the ways that you can actually use 3D printing to impact those different types of countries, like any country where you come from, and even if you're from here, like think of using 3D printing to boost most industries, and how you can take advantage of the growing industry. I would also say mainly connecting with people, and connecting with a space in general. That really helps to connect with a lot of things. And I'm really excited for the designers, right? More for the designers, because now it puts most of those design restrictions, it throws them out of the window, right? You're not able to do these curves, you're not able to do these things. Now with 3D printed, you throw all of them out, right? So there's actually design for additive manufacturing, which gives you all the opportunity to utilize certain features or certain cool designs to also optimize things. And so if I would encourage people to also connect with a lot of softwares that are coming up. I think Anthropology is doing a good job when in the optimization space. You have certain softwares like Fusion, which also has I think optimization and generative design features. I think another great software is Rhino, right? So Rhino is basically is known for architects, but the software is super powerful and it stretches beyond just architecture, because it has some cool plugins like Grasshopper, which you can use for a lot of things and a lot of optimization stuff to yourself. So it's an interesting space, both for manufacturers, and designers, and I think people should hop on that wagon.
Fascinating. Yeah, that's actually a really good point, is to kind of dive into the software side of things as well.
Yeah.
That's great. And then I guess, where can people find out more about you at Incra, what your work is at Siemens, or anything about you that you want to share?
Yeah. I'm more on LinkedIn, Benjamin Obeng. Also on usually on LinkedIn and Instagram. For what we are doing at the moment, we're developing our website for Adinkra. But I believe when you type in Adinkra, which is 3Dinkra, you would see some articles or some things that we did in Ghana, and some things that we worked on across what we've done so far. But we're coming up with our website that will connect a lot of people. What we're doing, it should be up by the end of the month, and we'll be able to connect with a lot of people, and you can purchase some of our products that we put online, and that'll be really great, because our also motive is to actually utilize most of the profits to actually develop or encourage kids and do some educational projects, and also do a lot of stuff in Ghana and in West Africa and Africa at large. So those are some of the places and some points that you can reach us.
Benjamin, this has been a phenomenal conversation. Thank you so much for taking the time this morning to hop on the podcast and talk about all things 3D printing. Your work is amazing. Your journey thus far with 3D printing is super cool to hear about, and I'm super excited to see where everything goes with what we're working on at Incra, and also your work at Siemens, and just the various different areas that you're applying to. It's cool to see someone that's like hungry for this environment of 3D printing and hoping just to push it forward. So yeah, thank you so much for hopping on.
Thank you for having me. Thank you.